A flash brighter than the sun tears across the Siberian sky. Trees snap like toothpicks. The shockwave circles the planet twice. 80 million trees fall in a perfect pattern radiating from a single point. No bomb, no crater, no wreckage. Just devastation on a scale that physics struggled to explain. June 30th, 1908. The Tunguska event. And we still don't know what it was. Siberia, 1908. The stony Tunguska River cuts through endless forest. Indigenous Evenki people hunt and fish these lands as they have for thousands of years. Russian settlers farm small plots carved from the taiga. June 30th starts like any other morning. Clear sky. Summer warmth finally reaching this remote corner of the Russian Empire. At 7:17 a.m. local time, a farmer named Semyon Semenov stands outside his home, about 65 kilometers from ground zero. Years later, he describes what happens next. The northern sky splits in two. Fire appears. The heat is so intense he feels his shirt burning. He raises his arms to shield his face. Then the blast wave hits. It throws him from his porch. He loses consciousness. Another witness, a trader, is sitting on his porch facing north. He sees a brilliant blue-white streak moving across the sky. It's followed by a flash so bright he has to close his eyes. The heat washes over him like standing too close to a fire. Then comes the sound, a deafening roar that seems to come from everywhere at once. Minutes later, the ground shakes. Windows shatter 600 kilometers away in the city of Irkutsk. Seismographs across Europe register what they think is an earthquake. In Britain, the night sky glows so brightly that people can read newspapers at midnight without a lamp. But in the forests near the Tunguska River, something else is happening. Trees are falling. Not one by one. Not in groups. All at once. 80 million of them. In a matter of seconds. They fall outward from a central point, creating a radial pattern visible from space. Though no one will see it from that height for decades. The explosion releases energy equivalent to 185 Hiroshima bombs. Between 10 and 15 megatons. It's the largest impact event in recorded history. And then silence. The forest stops moving. Smoke rises from scorched earth. Animals that survived flee in terror. The Evenki people, whose territory this is, speak of thunder that wouldn't stop. Of the sky opening. Of their reindeer herds scattering in panic. But the explosion happens in one of the most remote regions on Earth. No major cities nearby. No railway. No telegraph lines. Word travels slowly. The Russian government, dealing with political upheaval and the aftermath of the 1905 revolution, doesn't investigate. For 19 years, the site remains virtually untouched. Local people avoid the area. They call it the place where the god Agdi destroyed the forest. Hunters report that the devastation is total. Animals are scarce. The land feels cursed. In 1921, Soviet mineralogist Leonid Kulik reads old reports about unusual meteorite falls in Siberia. One report mentions a massive explosion in 1908. Kulik becomes obsessed. If a meteor this large struck Earth, it would contain valuable minerals. Perhaps even diamonds formed from the impact. He petitions the Soviet Academy of Sciences to fund an expedition. In 1927, they finally agree. Kulik assembles a team and heads to the Tunguska region. The journey takes months. There are no roads, no bridges. They travel by train, then by horse, then on foot. When they finally reach the site, Kulik finds something he doesn't expect. The devastation is real. The forest is flattened for miles. But there's no crater. A meteor impact should leave a massive hole in the ground. This has none. The fallen trees point outward in a radial pattern from a central spot. At that center, something stranger. A small area where trees are still standing. They're dead, stripped of branches and bark, but standing. Like telephone poles in a blast zone. Kulik spends months searching for meteorite fragments. He finds nothing. No impact crater. No meteor chunks. No trace of whatever caused this. He returns in 1928, 1929, and 1930. Each expedition brings more questions. The pattern is too perfect to be natural. The energy required is immense. But where did it come from? Other scientists begin studying the reports. British astronomer F.J.W. Whipple analyzes seismograph data from the time. He calculates that the explosion occurred about 6 to 10 kilometers above the ground, not at ground level. An airburst. That would explain the lack of a crater. But what exploded in midair? By the 1930s, theories multiply. A meteor that disintegrated before impact. A comet made of ice that vaporized. A natural gas explosion from underground. Each theory has problems. Meteors don't typically explode in airbursts. Comets should leave some trace. Underground gas wouldn't create such a perfect radial pattern. Then World War II happens. Research stops. The Tunguska event becomes a footnote in Soviet science journals. In 1958, a new expedition arrives led by Kirill Florensky. Technology has advanced. They bring better cameras, magnetic sensors, radiation detectors. They map the entire blast zone. The area of total devastation covers 2,150 square kilometers. They find something interesting. Microscopic particles of melted rock embedded in the trees. Chemical analysis shows high concentrations of nickel and iridium. These elements are common in meteors, rare on Earth. It's the first physical evidence linking the explosion to an extraterrestrial object. But questions remain. If a meteor caused this, where is it? Even if it exploded in the air, fragments should have survived. Meteorite impacts leave evidence. The Tunguska site has almost none. In 1960, 3 Soviet scientists propose a new idea. What if it wasn't a meteor at all? What if it was a small black hole passing through Earth? The theory is wild, but the physics work. A black hole would explain the lack of debris. It would pass through Earth like a bullet through water, causing an explosion on entry and exit. Other scientists quickly dismiss this. A black hole would create seismic events on the opposite side of Earth. Nothing was recorded. The theory dies. Then comes a more disturbing proposal. In 1946, science fiction writer Alexander Kazantsev publishes a story suggesting the Tunguska event was caused by an alien spacecraft exploding in the atmosphere. It's fiction, but the idea gains traction. In the 1960s, during the height of UFO interest, some researchers seriously consider it. The lack of a crater, the precision of the blast pattern, the absence of debris. Could it be evidence of technology, not nature? Mainstream science rejects this. There's no credible evidence for it. But the absence of clear proof for natural causes keeps alternative theories alive. In the 1970s, computer modeling advances. Scientists can simulate explosions, calculate trajectories, and model atmospheric effects. Multiple studies confirm the airburst theory. An object, likely a stony asteroid or comet, entered Earth's atmosphere at tremendous speed. The friction and pressure caused it to heat rapidly and explode before hitting the ground. Modern analysis suggests the object was between 50 and 80 meters in diameter. It was traveling at roughly 27 kilometers per second when it entered the atmosphere. The airburst occurred at an altitude of about 8 kilometers. The combination of altitude and energy release created the unique blast pattern. trees directly beneath the explosion remained standing because the shockwave came straight down. Trees farther out were knocked over by the horizontal component of the blast. This explains the radial pattern and the central zone of standing dead trees. In 1999, Italian scientists analyzed peat samples from the region. They found tiny particles of space rock embedded in layers corresponding to 1908. The composition matched carbonaceous chondrite, a type of primitive asteroid. In 2013, a team analyzed resin from trees that survived the blast. They discovered microscopic diamonds formed from the extreme pressures of the explosion. The evidence keeps pointing to an asteroid or comet. But some mysteries remain. Why was there so little debris recovered? Why didn't the object leave a clear chemical signature across the entire blast zone? Why do some trees show damage patterns inconsistent with a single airburst? Some researchers suggest it wasn't a single object but a cluster of fragments from a broken-up asteroid. This would explain the multiple pressure waves some witnesses reported. It would also explain why the blast zone isn't perfectly symmetrical. Others propose it was a comet, which would explain the lack of substantial debris. Comets are mostly ice and would vaporize almost completely in an airburst. Only the rocky core fragments would survive, and those could have scattered widely. The truth is, we'll probably never know for certain. The site has been disturbed by decades of expeditions. Whatever physical evidence existed has been contaminated or removed. We're left with eyewitness accounts, old photographs, and indirect measurements. But we can be fairly confident about what happened. A space rock, either an asteroid or comet, entered Earth's atmosphere over Siberia. It exploded in midair with the force of a nuclear weapon. It flattened 2,000 square kilometers of forest. And then it vanished, leaving almost no trace. The Tunguska event reminds us how vulnerable we are. This happened in one of the most remote places on Earth. If the same object had hit 6 hours earlier, as Earth rotated, it would have struck Moscow or St. Petersburg. Millions could have died. Events like Tunguska happen roughly once every few centuries. The next one might not hit empty wilderness. That's why space agencies now track near-Earth objects. That's why scientists study asteroid deflection methods. Because Tunguska taught us that the threat from space is real. The forest has regrown now. Young trees cover the blast zone. But the fallen giants, preserved by the cold climate, still lie where they fell over a century ago, pointing outward from a spot in the Siberian wilderness. A monument to the day the sky exploded, and no one knew why.
Subscribe to the channel, or next time I'll make the explosion happen right on your head.